So before we kick off with our discussion on NEC compliant cable glands, I would just like to welcome our lovely panel of experts, as we have some new faces in this session. So we've got Henry Turner, Business Development Manager from Hawke. If you want to give us a little wave, Henry. We've got Marty Cole, Certifications Manager at Cable Canada. We've got Matt Ogden, our Senior Product Specialist from Hawke, who you'll probably know from a few of our previous sessions.
Hello.
We also, oh, sorry, Matt, cut you off a little bit there. And we also have Mike Shinner, who will be monitoring the chat. So don't be afraid to ask him some questions as well in the chat. And he is our Fittings Product Manager from Killark. So let's kick off the questions. So the first question we have is about changes in the markings on our products. So Henry, if you want to talk a little bit about that to kick off with.
Sure, I'll be glad to. We've had, as of last year, we did have a change in some of our, specifically the Class 1 Div 2 rated cable glands. It's really for a matter of clarification, more of a marking clarifications. It's not a certification that we lost, but it is something that is required clarification from the certifying bodies. So within the standards itself in a Class 1 Div 2 area, you typically your options is either to have a compound/barrier gland, or some applications will also allow if you have just like a sheet steel enclosure of some type with hermetically sealed devices or no arcing or sparking devices, then you can use a non-compound barrier type gland in those applications. But because we were marking the cable glands as Div 2, which was allowed by the standards, they were unfortunately being misapplied in the field. And we were having Class 1 Div 2 marked non-barrier glands were actually being installed into explosion-proof with arcing, sparking type devices inside the enclosure. So after various inspectors and different things like that got involved, and even went to the certifying bodies, advising them of some of these issues they were finding in the field, then the likes of UL, CSA, etc., reviewed that and basically came back, and just to eliminate any potential confusion and just to try to mitigate any type of issues like that, to ensure the products are being applied in the field correctly, then they basically went to all of the cable gland manufacturers, and anybody who had a Class 1 Div 2 marked non-compound gland, they requested that we remove those markings. So that's probably the biggest change that we've had on our markings as it relates to the Class 1 Div 2 cable glands. And it's really just more of a clarification on the markings, but it is something going forward that everybody will see across the board with any of the cable gland manufacturers. So today, the only cable glands we can mark Class 1 Div 2 are going to have the compound chamber built into the product itself. You can still use the other glands in a Class 1 Div 2 area, but they must be applied in accordance to the standards. So that's the basic update.
Perfect, thank you. And Marty, is there anything you would like to add to that?
Yeah, and to what Henry was saying, the certification agencies haven't quite caught up with all the manufacturers to have them update their files, and that's a lengthy process once they make a change. So you might find some that are marked that way, but they'll be losing it when their file review is done. So that's important to understand. If they're telling you we have it and somebody else doesn't, that's not correct. Everybody's facing this.
Perfect. Thank you for those points. Matt, is there anything that you'd like to add there?
No, I think Marty and Henry have pretty much covered that in the correct way. I think I don't think there's anything else to add.
Perfect, thank you. Great answers there. So the next question that we had within the chat was, what are the main differences between EN/IEC compliant glands and NEC glands? So Marty, if you want to kick off that one.
our world is a little bit different. In North America, we certify cables, and in the rest of the world, they just have to comply with the standards for those cables. They don't go through a certification process. So an IEC type cable gland would not be certified with a cable installed. It would be certified with a test device, mandrel, to see if it complies with the explosion-proof properties. In North America, since we certify cables, we also certify the glands to go with specific cables. So there's a match, and the gland will tell you which cables are suitable to be used with that cable gland. If you have a different cable, it may not be suitable with that because it isn't certified for that purpose. So that's a huge difference between how North America approves cables with cable glands, and that process is independent in the rest of the world. Does that make sense?
I think it's good to add there that we as a gland manufacturer have to actively go out and ask for this certification to go along with the cable types that people are using. It's not just a mandatory thing. We have to actively go out, and if we see a requirement, we go to the certification bodies and ask for that to be added to our certificate. So it isn't, like Marty said, it's not an automatic thing. It's something that we have to go out and obviously seek.
Right, and we keep up to date with what cables are being used by industry and certify them accordingly. Certainly for North America, that's we must do that for people to use it. It's fairly static within IEC as to what cables people want to use, and our glands accommodate them, and we investigate that internally to make sure that we fit them right and take care of other issues such as cold flow and things like that that was discussed in previous things. So
yeah,
perfect. And just to touch on that kind of a little bit more, and we'll touch on the kind of benefits of the nuclear compound part that we have now. But for Hawke's new range of cable glands, Marty, could you talk us a little bit through the certification process that they've been through in general for NEC, specifically the compound part as well?
So we have a non-metallic potting chamber in our new cable gland, which is a first for North America that didn't exist here before. So it allows you to better inspect the gland. There's a lengthy process to get the materials that the certification agencies will agree to make sure it works with, maintains the explosion-proof properties of the cable gland. It's not a quick fix in North America because they have lots of different rules for materials and everything else. So it isn't something that happens overnight, and we spend a lot of time getting that. The new compound, maybe Matt can talk about how quickly that sets and the advantages of that over the competition.
Yeah, of course. Just touching on just a point, obviously, with the previous question, obviously we searched extensively to find a suitable material that will give us resistance to some of the tests that we have to go through to meet that the North American standards, like the chemical test, the hydrostatic test, the explosion tests, and to ensure that the compound matched the silicon that we selected and that it passed all of these extreme tests that you have to go through to meet that UL or that North American standard. Obviously was something that we had to search through numerous different processes and research projects to get to that point.
The UL test, sorry. Go on, the UL test for plastics is actually a brutal test. It's a 13 chemical soup with a lot of really terrible chemicals that nobody should be exposed to, but they put it through a torture test. And we find with a lot of international products, they may be perfectly good products, but they will not pass the plastics tests that UL puts forth. So that's an important point to note, that it's an investigation to find the correct materials to meet all those test requirements.
And I suppose that goes some way to explaining why this is the first non-metallic compound part as well, if it has to go through those sort of tests. Yeah. I mean, we've kind of touched on a few of the benefits of the compound part. Marty's touched on them, but Matt, is there anything you'd like to expand on there?
Yeah, I think that's a perfect segue into kind of what was there before and what's there now. So obviously previously we would have had, I'll just bring up a quick slide on the screen actually just to show the difference. So previously we would have had something like the brass metallic pot that you see on the right hand side of the screen. So that was obviously that would give you a flame path. That's obviously a traditional way that North America would see cable glands with compound chambers. But we obviously manufacturing in the UK and being a global supplier of cable glands, obviously saw the benefits of being able to offer something with inspectability. And our previous design, before we kind of moved on to this generation of cable glands, which we switched over to in July 2019, we had a removable compound chamber that was made of a Santoprene plastic material. Now you filled that with a putty, and you could remove that once it was hard, and you could see whether it was filled correctly. And it had filled all the voids, and the putty had moved around all of the cores. Now, obviously, with that design, and obviously the movement that we are definitely behind the curve on, which we're trying to obviously catch up with now, is obviously the introduction of a liquid pore seal. Now, with a liquid pore seal, it acts slightly differently when it goes harder, and the adhesion between the actual epoxy resin that we use and the plastics that we use in these compound chambers, it wasn't possible in the old design. So we had to develop something new. And removing that compound chamber off of the epoxy liquid putty was not really a viable option. So that's when we started to look at see-through materials, and obviously the clear silicon compound pot is obviously where we pushed, and obviously pushed for certification to get that over the line. And obviously the inspectability aspect of it, you can see as you're pouring, and you can ensure that has been installed correctly first time every time. As the material flows around all of the cores, it fills up. It's night and day between the black compound that we supply and the clear resin, so you can easily see that it's been filled properly.
Perfect. Thank you. And just before we move on to maybe some more of details about the types of compounds that we offer, we have a question in the chat from Daniel about the chemicals that are in the soup that are part of the testing. Marty, do you have anything you could expand on there?
I'd have to look them all up. There's benzene, toluene. I don't have the list. Without the list, it's impossible. I'll find the list and give it back to you in a minute.
We can send that over to you, Daniel, after this, if you're interested. So Matt, did you have something you wanted to expand on there, or are you happy for Henry to talk a little bit more about the types of compounds we offer?
No, fire away, Henry. It's I've got a video as well if you want me to play that in the background of obviously the process, but I'll bring that up as and when we start talking about it.
Sure.
Okay. Yeah, so the different types of resins that we have, we still offer the standard 2-part compound that you can mix up. The biggest advantage of that, though, now, that used to have some longer cure times associated with it, but now your more popular sizes, up to say like our size C, C2 glands, we now offer that with a quick curing. But anything larger than that's going to go into your standard, and that's just because of the amount of work time that's going to take to fill the voids and everything else and provide your seals around the conductors. But you're definitely going to have the quick seal or the quick curing on the smaller sizes, which is by far, you're going to have more of those on a job than you are the larger ones. And then the other option, which Matt has alluded to, is the injectable resin. It makes it very simple to do your installation, and the cure times on that is going to be, roughly, and there's a temperature chart associated with that. But what I've seen here in the Gulf Coast, and even on East and West Coast during the summer months, we've seen some of that get to what they call a shore hardness within 15 to 20 minutes. But you obviously want to make sure that you're looking at the temperature gauges and making sure that it's properly cured before you start handling it afterwards. But there's pros and cons to both. With the QSP version, which is your 2-part compound, if you're having to do horizontal installations, then you still have the ability to do that, and then you also have the faster curing times. With the injectables, then you're going to have that. That's going to be probably about a 30-minute cure time, irregardless of the size. but that's going to be predominantly for, you will have to make sure that you allow that to cure in a vertical position, but that will, you're still going to get your faster cure times. And the biggest benefit to all this is that they use the exact same compound pot, the clear pot. So with both resins, you're going to get your full inspectability. You also get your faster curing times, but you'll be able to manipulate it. As you can see with the video that's going on right now, the silicone pot is flexible. So if you see any voids in the resin itself, you can simply just manipulate it, and you can actually watch the bubbles go up to the top, so that you don't have any bubbles or voids in the actual termination. And it's the same with the two-part compound. You mix that up, you pack it around, and when you slide the pot over, then you can manipulate it, and you can continue to pack more compound in. Because that's really the biggest question I get as someone who goes out and does a lot of the gland termination trainings from the guys out in the field. With the compound, how do you know you have enough? How do you know you don't have any voids, whether it's the injectable or the other? And to be quite honest, with the brass pots, you don't really have that with the metallic pot. But with the clear pots, you can clearly see that you don't have the voids, and you've got it cleared, and which makes it easier for the installer, so they know they're doing their actual termination correctly, and ultimately makes it easier for the inspectors and the clients to make sure that they're getting a proper seal, which is obviously the most important thing when you're looking at explosion protection. So,
and one thing to touch on there is just the the application of certainly the express resin, and using the syringe with the nozzle that pre-mixes everything for you. So as you push the two parts of the syringe into one nozzle, it mixes everything, comes out of the tip of the nozzle as a 1-to-1 mix. That mix is obviously in a perfect ratio to ensure that everything happens as it should do. And then obviously, as Henry said, you've got a cure time of a total of 30 minutes in normal ambient temperature, but it actually gels in around 8 to 10 minutes. So after 8 to 10 minutes, you can then turn it horizontal, so you don't have to be vertical anymore. Obviously, the ability of that is then you can continue to work. You could rack these up 10, 20 at a time. You can go along. We also sell larger syringes, up to 250 mils. So you could use multiple or fill multiple glands with one syringe. And then as you get to the other end, the first one's cured, and you can continue with your installation rather than previously having to wait, certainly with the compound, where you might have to wait 1 to 2 hours with the QSP, or potentially 24 hours in some conditions with the longer curing putty. So it is a much faster process, and the application is just much faster than previously we've had, and what we believe any of our competitors as well.
Perfect, thank you. We have a question in the chat from Bob Johnson. Thank you for your question. Is the ICG 653 and 753 basically now one and the same gland design for braided cable?
It is. It's apart from the marking, apart from the certification, the actual design of the product is the same, and it's only because we need to have that US marking, that North American standard on there. And we have the ICG 653 for the rest of the world. Henry, do you want to touch on that? Obviously, it is now the one in the same with regards to the 753 and the 755 that we used to have.
Yeah, you are correct. They are virtually the same. It's just going to be the markings on the glands are going to be a little bit different. The actual certifications are going to be identical. The 753 series is going to maintain the UL certifications as a Class 1 Div 1 cable gland. The ICGs, and I know this kind of leads into one of the other questions that we had, but the ICGs, in effect, we offer a conversion kit that the 501-453 universal you can convert into an ICG 653. So in those cases, you could actually take a 501 and then convert it to an ICG that could also be used in the same areas as a 753. We kept the glands separated like that because from a specification standpoint, and we still have a lot of customers that utilize the 753, throughout their systems, whereas the ICG will probably predominantly end up at some point. We will have that offered as part of a conversion kit, which I know, Matt, that was one of the questions you were going to address.
Mm-hmm.
Did I know?
I mean, since you're on it, would you like to
Yeah,
expand
well.
on the conversion kit at all, Matt? Or
Yeah, so when we were obviously looking at the initial design phase of this new range, we obviously wanted to offer versatility, inspectability, all of the things that we design, all the parameters that we design around at Hawke. And one of them things was obviously looking at our flagship gland really as a global gland is the 501-453 universal. That's a diaphragm seal. It's there designed to limit the amount of potential cold flow and the pressure that's applied to an inner sheath of a cable, and essentially reduce that. And that's, like I say, one of our most spec'd cable glands that we manufacture. Coupled with that, obviously, we see in the market the changes in standards with regards to effectively filled cables and the 3-meter rule, certainly within the rest of the IEC world. And also, if it's under 3 meters, we have to put a barrier gland on there. And if the cable doesn't meet an effectively filled test, where gas could potentially migrate through the cable, then we have to fit a barrier gland. Now, because the onus is on the installer, and sometimes that the first point in which they're seeing the equipment that they're supposed to be working with is actually on site when they're actually physically putting it together. Now, if it comes to that point and they realise that actually a barrier gland should be fitted, then what we don't want to do is have them having to either fit the wrong cable gland or have to wait 6 to 10 weeks for a new cable gland to potentially turn up so they can actually do the job properly. So what we did was we tried to obviously have as many common parts within the gland itself. I'll just bring up another. So we wanted to have as many common parts as possible, and as you can see here, this is the bottom one with the black boot is the 501-453 universal, and the top one is the ICG 653 universal. And you can see that 4 of the parts in each gland type are actually the same. So what we wanted to do is make that versatility by having conversion packs available. These are much quicker for us to manufacture. We can have these stocked on shelves. It means that distributors, us as manufacturers, can respond much faster, and we can substitute certain parts. So if you look at the 51453 universal that you may realise that needs to be a barrier gland, we can substitute this inner seal, and we can substitute this black boot, and we can provide a conversion pack with 4 components. One being a resin stop spigot. That's got a seal inside that stops any resin pouring down the inside. If you were to specify the express liquid resin, you would get the clear compound chamber and you would get a red deluge boot. Then you would also pick whether you want a putty style resin or whether you want the liquid style. Now, for us to be able to do this, we had to work closer with our certification bodies to ensure that we could mark the product correctly. So the deciding factor is actually the colour of boot that is actually installed on the gland as when it's finished. So the marking actually states 501-453 universal black and ICG 653 universal red, and that gives the ability to mark one product with 2 different uses, and gives us the versatility of two products within one potentially.
perfect, thank you. Henry or Marty, do you have anything you'd like to add on the topic of the conversion kit before I move back into some questions that we've received in the chat?
From my angle, the only thing to be aware of is when we first launch these glands. So right now, our inventory here in the U.S. is still split between the 501-453 universals and the ICGs. There is the move to try to standardize on 501s and then just offer the conversion kits for the ICGs, but then still have the other available for those customers who want to solely purchase the ICGs. But the inventory we currently have is going to be split between, we're going to have the ATEX, IEC, EX, and CSA certifications on the 501s, and then we'll also have the ICG as a standalone gland. We've just recently received the Class 1 Div 1 certifications, so we will be able to start marking the 501s accordingly, with the caveat of having the ICGs with the red deluge boot. So those are available now, but we would have to get those glands from the factory out of the UK. So we've got a little bit of a time lag as we work through some of the certification. It's done. It's all good. It's just we do have a little bit of an inventory lag right now, and to catch up with the new certifications and everything. So just for those from the US, that's kind of where we stand on our inventory on that product split right now.
And that's perhaps a shorter term thing. We are changing to be what you're talking about. So the inventories will get themselves adjusted, but that's
Yes.
a huge thing for the user. That's a really big thing for the user, because he can stock kits in a bunch of glands, and he doesn't have to have 2 different versions and be out of the wrong one.
Right.
Yeah, great point. Thank you. So I can see that Mike has been answering some of the questions in the chat. Thank you, Mike. But I think for the sake of everyone that's on here who's not looked at the chat, I'm just gonna refer back to the first one that we received from Eduardo. He asks, so concerning the cable used and cable gland, is it allowed to have a sealing ring cable gland for Class 1 Div 1 once the cable is approved?
I'm not sure I completely understand the question. Can you try to, is it in the chat there?
It is indeed.
I believe if he's saying a sealing ring is as though, I mean, in the NEC, Class 1 Div 1 is very specific that if you have a cable gland and cable in that area, the cable gland must be a compound sealed cable gland.
Yeah.
And in a Class 1 Div 1 area, there's no options. So they're very clear in how that has to be applied.
And it's going into a threaded entry. So if what you mean by a sealing ring is what seals it against the enclosure.
Eduardo said compression ring, yes, in the chat.
Okay, so if it's an NPT thread, the likelihood of that actually engaging is a little lower than if it was straight threaded entries. And in US and much of Canada, we use NPT type threads. So the sealing ring doesn't do a lot to help seal the gland against the enclosure. It's the threads that do that.
I think Marty was referring to a compression type seal, so where you're basically displacing the seal to seal onto the cable.
Okay, I took it as being a sealing ring. Okay, but
I mean, either way, obviously they've got an answer. They've got 2 answers there. One is if it's an internal compression seal, as in a displacement seal, then no, in Class 1 Division 1 you must use a barrier gland, and then obviously if it is a sealing washer, then obviously that would only probably be effective on a metric type thread, where you're obviously putting compression between the gland and the enclosure itself.
And one thing to remember when you're installing any hazardous location equipment, like explosion proof or in zone 1 flame proof equipment with cable, it has to be sealed. It needs a sealing gland. Even if the product is marked factory sealed, the NEC requires you still have a sealed connector going into that, because the assumption is that cable cannot protect the enclosure. A conduit is different. You may not need a seal, or you don't have to seal a factory sealed device with conduit, but you do have to seal that device if it's with cable. So that's an important thing to remember as well.
So Mike thank you for your comments in the chat there. Mike's made the point that sealing rings and compression rings are typically used for ingress protection to keep dust and moisture out. And Eduardo has said that for IEC, they used to have the cable gland for EXD applications with the compression sealed.
And you can still do that for IEC.
Yeah, but that's why he's asking it about NEC applications, just to clarify. Yeah. So does that answer your question, Eduardo? You can respond in the chat if you like. Perfect. Correct, thank you. Okay, well, moving back to some of the questions that we were asked via our form. One of the questions we get asked quite regularly is, how tight is too tight when doing up a cable gland? So Henry, if you would like to kick off with that one.
Sure. Yeah, that's probably one of the biggest questions I get, especially when we go out and do any type of a gland termination training. You know, very typical of kind of how, I must speak for us guys. If you see a thread and you still see threads exposed, you have a tendency to just grab a bigger wrench as it gets tighter, and you keep tightening until you don't see any threads. If you do that on a cable gland, you definitely have the potential of over tightening that gland, because it does not require near that amount of force to do that. So we get asked the question, how tight is too tight? And just kind of in accordance with our assembly instruction sheets, you simply just have to tighten the back seal enough to where you form a seal all the way around your cable, and then one full turn with the wrench. And that additional turn with the wrench is just to give it that mechanical retention. And so that's probably one of the biggest things we see out in the field is the glands are over tightened to the point to where you can even see the cable is bulging around all the way around where the seal is in contact with it and stuff like that. But so, you know, paying attention to the assembly, and all the gland manufacturers do things a little different. So it's very important to make sure you understand that going forward on your installations. But Hawke is very simple in their installations, and it's literally form a seal around the outer jacket, then one full turn. And to further aid in that, what we've also introduced with, along with the clear sealing pot with the new glands, we've actually removed the spline from the threads from the middle nut where the back nut comes into contact with the middle nut right here. And since we did that, we were able to introduce a tightening guide. And the dimensions are both in metric and inches. So now you can simply, with the exact same instructions of forming a seal around the outer jacket, one full turn, that should put the edge of the back nut in the range of the ranges that are actually marked on the dimensions marked on that between the middle nut and the back nut. So it just kind of gives you an additional guide. You know, so if it looks like you check your dimensions and then look at the guide as you're tightening it, it just gives you a reference point. Because we also get asked, a lot of people ask, well, do you have any torque specs? It's very difficult for us as a manufacturer to give a torque spec because of all the variances in the cable. We manufacture a gland that has global certifications on it, and as a result, we can deal with all types of different types of jackets, whether it's thermoplastic, thermoset, cross-link. There's irradiated jackets, and all of those jackets are going to give different types of yields to the compression. So it's always very important just to make sure you look at those instructions. But I'm probably a little biased because I worked for Hawke for so long, but Hawke is by far, if you follow the instructions, it's one of the simplest glands out there to put together. And there's no reason to over tighten these glands with the different types of things that we've built into it now, with the tightening guide and some of the very simple instructions to do that. So, torque ratings, if we have someone who absolutely has to understand or wants some type of instructions, then we would actually have to test that cable on the gland, and then we could issue torques on that, but it would be very specific to that cable. It's not something that we can just issue out there, but you really don't need it with the instructions that we provide. Again, you tighten until you form a seal, one full turn, and then you have the addition of the sealing ranges on the actual tightening guide itself built into the product. So it's not an extra device or tape or anything else that you have to wrap around the cable. It's actually built into the gland, so it doesn't require any additional items to figure out if you've tightened it correctly.
Just going to say that if yes, you could over tighten these, but it doesn't give you a better seal. You know,
Correct.
over time it will still leak water. If at the point you just leave it and you don't inspect it and nobody ever comes back to it, eventually things move. You know, the material science, it happens, and materials move between one another, and ingress will eventually get in there. That's what water does. It eventually is going to get everywhere that you don't want it to, which is obviously why we have regular inspections and maintenance and all of them things. But at the point of installation, you tighten it enough not to let water in. You know, if you have a tap on your sink, you tighten it, you tighten it till the water stops. You don't have to get your wrench out to keep tightening it until you can't tighten it anymore. So once it is in position, it's tight enough as per the assembly instructions, as per the tightening guide. That is enough to ensure that until the next maintenance routine occurs, it will give you enough protection.
Perfect, thank you. Marty, anything that you'd like to add on that topic?
No, I agree with the other guys that people have a tendency to over tighten stuff. That's not a good idea.
Perfect. Thank you. Well, just going back to the chat, for those of you that haven't seen some of the questions that have come in there, Bob Johnson has asked, what thread lubricant does Hawke recommend, if any?
I mean, what we would typically recommend is just, you know, as far as actual thread lubricants, you just want to make sure you don't use anything that's going to set up. It cannot be a hardening type thread lubricant, because that will affect the ratings of it. You could potentially, if you were to have to deal with the gland's not going to function correctly if you use some type of a hardening lube on the threads.
And again, for those of you who haven't seen that, Mike has recommended the Killark LUBG series.
And it's not a good thing to use Teflon tape either.
Correct.
That's not really allowed.
No. I mean, from a Hawke point of view, we have done tests on non-setting sealants, Hylamar being one of them. If you miss an IP washer or whatever, we have tested Hylamar. I think there's 4 different varieties of Hylamar that can be used. It is a non-setting compound sealant that can be used on the threads. Obviously, if you use a hardening one, you're potentially blocking flame paths. So yeah, that's something else that we've done previous tests on at Hawke to ensure that we can maintain IP if IP washer is missed and you don't have to disassemble everything.
Perfect. Well, we have about 4 minutes left, so if you want to get your questions into the chat before we finish up, that would be great. I can see that Eduardo has a couple more questions for Mike in there. But I mean, Matt, Henry and Marty, are there any other questions that you've generally had in the field that you'd like to bring up now?
About the only thing additional thing, I mean, you know, the topics of over tightening, and then of course the compound is always going to be the most popular ones that we see, but also just if you really just from an overall installation perspective, you know, refer to the AI sheets. The AI sheets are how the Cable Glands are certified. It's how we submit those same certifications, or I'm sorry, the same AI sheets to the certifying bodies to get our certifications. There's lots of people will take a lot of interpretations. There's a lot of inspectors that are out there and may not have the same training, or they assume that one gland can be installed the same way as they think they should all be installed the same way. So it's very important when you're interacting with your inspectors or you're doing your installations, you know, the AI sheets essentially are your Bible when it comes to that, and any type of interactions you're having with inspectors or just your own internal requirements, if you refer to those AI sheets, you won't have any issues. And the Cable Glands are very simple to install. Just stick to those AI sheets, because that's how we get our certifications, and they're correct. And if you follow them, you'll be in good shape. So
if you do get any kickback as well from inspection, then obviously, you know, we're here to help. We can provide you with documentation, letters, statements, whatever that may be, just to kind of ensure that you know that you're fitting it correctly, and you should have backup from a manufacturer to ensure that you can stand up strong in front of people to take that.
And the inspector doesn't always know more than the installer. That's why we're
True.
here to help. Sometimes they need it. Sometimes they need help understanding the rules as well.
Okay, perfect. Well, thank you very much, guys. In terms of our next session, we are looking to do a joint session between Killark and Hawke. So we'll talk a bit more about Killark and Hawke's cable glands and fittings range a little bit more together in the next session. So it's good that you've asked that question there, Clayton, in the chat. So we'll give you details about that shortly once we're ready to promote it. But that's something you can all look forward to. As I mentioned before, we have been recording this session, so we will get you all a recording of this session afterwards. And if you have any more questions at all for us, please don't hesitate to send them over. Thank you everyone for joining, and have a lovely day.
Thanks, everybody.
Thank you.
Thank you.
Thanks, everybody.